Hello everyone, thanks for watching this video. A little bit about me. I'm Pawan Kumar Ogireddy. I am based out of Houston, Texas. I'm a certified Mulesoft Integration Architect, and I have around 10 plus years of experience working on integration projects across different domains. Before we get started with MuleSoft, I wanted to give you guys a little bit of background on enterprise systems integration. So enterprise systems integration is a concept by which we try to connect existing systems so that they can share data and communicate. Usually, there are certain data flows that are configured across the organization in order for the systems to communicate with each other and satisfy the business needs. Some of the challenges working with integration projects are here. So first is protocol. So there are different types of protocols like SOAP, REST, and FTP, and then the list just goes on for different native protocols as well. So using these protocols and our data to intercommunicate between systems is challenging. The second is data format. Again, we have a bunch of popular ones here like JSON, XML, binary, Parquet. There are several others like Parquet. So data can be in any format in these systems. The next is invocation styles. So systems may want to interact with each other in an asynchronous fashion, synchronous fashion. Uh, by these, what I mean is there may be an instant feedback that might be needed for certain kinds of applications. There may be some applications which can do the work in the background and notify later. There are other kinds of applications which use batches. So in batch processing, you would take a list of records and then process them through different systems and then ultimately get to a result. Uh, Obviously, the complications can be higher as well. You can have a mix and match of these invocation styles and different formats that you would be dealing with. The next one is lifecycle management. So this is more of a process and a people aspect. So each team using these applications across the systems may follow a different project management methodology like SDLC or Agile. They may be doing operations and maintenance in a different way. So catering to all these needs and getting to a common philosophy of how to deal with integration projects is really challenging. Uh, the next most important challenge is error handling. Uh, so you have all these applications which are working in silos and they have their own way of handling errors. And the errors are also again in a silo. So when we create integration between different projects, then often the errors are not propagated and system, let's say we have a system A and system B being a, a part of the communication, both of them cannot pass on the errors because we always focus on the data or the services within them and often uh, ignore the errors. The next challenge is uh, monitoring. So while doing these integrations, uh, we want to know what's the latency between applications. Like, let's say you have a payment system which is sending a transaction to another system and it comes back after maybe an hour. So it may breach our SLA. So we want to know how many transactions are going in per second, what's the latency, and then missing events, right? So system A may be communicating with system B, and then we might be missing some events there. So uh, these challenges have to be tackled in order to fulfill any integration needs. So with that being said, let's move on to the next slide. So in this slide, I'll talk about the current state of integration itself, right? On the left-hand side top, you can see more of a point-to-point based integration. Uh, so this is a typical state of any Fortune 500 company that you can say. We have a couple of SaaS-based applications, custom applications, IoT, uh, several applications are being built, and while the systems are evolving, uh, due to the time crunch or due to the architectural failures, uh, a point-to-point integration is preferred because business wants results quickly, and then it's often easier to do a point-to-point integration. But often business doesn't focus on maintainability and operational aspects of it. And on a long run, these systems can be challenging. Uh, so uh, these systems, again, are a bit evolved in certain organizations, and they've been using enterprise service bus, a central bus, basically. So this is a bus which will allow applications to communicate between each other. This seems to be a very graceful solution because we have a central system which is uh, responsible for this communication, and it takes care of a lot of our needs. But for instance, if the service bus it goes down, right, then our entire integration goes down, and all these applications will stop communicating with each other. And also the service bus itself can have a lot of load in terms of applications, and then it might get challenging to deliver on the SLAs because of the slowness here. The other challenge with this is the applications themselves may have a lot of data which is reusable, and then it is close to impossible to unlock those data silos and then use it across applications. So the reuse component can be a bit challenging here in terms of data and code. So that being said, let's go through a quick use case to get you guys a bit of more background and familiarity of what I'm talking about. So this is a example of a point-to-point based integration. We are trying to create a auto loan calculation application, and this should also accept payments from the user. So this project was given to a developer. So this is what the developer came up with. So here there are a couple of modules that the developer developed, and these modules are again interacting with different systems in order to pull the data. Like here we have a Salesforce system which is giving you customer profiles. Similarly, there is a call center portal which again has customer portals and customer data, and then you have some custom databases. So these are different channels that business is using to pull customers in here. And there's a loan status application, which again, based on the customer profile, decides whether to give a loan or not. And this again uses the ledger system to validate that loan We have a payments calculator again, which is dependent on customer profiles and ledger. And then after the user is shown an amount to pay, uh, we want our user to either choose a payment gateway like PayPal or Visa to make the payment for a successful loan. Uh, so the developer was able to finish this on time because everything was done point to point, and it it worked as expected. However, there's limited reuse here because of the point-to-point integration, and the system itself is brittle here because let's say the database is on maintenance, then the customer profile module goes down and the entire system goes down. And it's difficult to govern because all these point-to-point integrations have certain governance logic, wherein each of these systems are being owned by different teams in your organization and have a different governance model. So it's often difficult to govern that on the app level as well. So down the line, right, your business wants to innovate and they want a mobile app now. Uh, so, uh, so obviously innovation comes with a very tight deadline. So developer was given uh, a deadline to finish the mobile app very quickly. So the first thing that the developer does is that he copies the entire web application, the backend of the web application, and he creates a new project, and then the project then again interacts with the same application, has the same code, and and then a mobile API is created, and then you guys are live with a mobile app now. But if you notice the modules here, the challenge is that the code has been duplicated here. And I don't blame the developer. It's just the logistics that has worked out. And then your uh, the backend technology might be a Java or a .NET app, and then it doesn't give much of a flexibility to modularize your code in order to use it uh, on the mobile app. So that's again a challenge here. So a couple of things I wanted to mention here. Let's say uh, tomorrow you want to change the payment calculator logic, right? So you have to do it in two places. So that's the configuration that I wanted to emphasize on here. And for and the other one that I wanted to mention is, let's say you have a payment gateway bug and you want to resolve that, then you have to resolve it on two different places. So it becomes a maintenance hell, and uh, as and when you have new innovative projects, you keep duplicating the code again and again. So with that being said, finally we come to the MuleSoft part. So before we get started with MuleSoft, I wanted to give you guys a little bit of history on what MuleSoft is and uh, philosophy behind it. So MuleSoft was created back in 2006 because of several challenges that integration developers were facing with respect to boilerplate code and unlocking the data. So it was named MuleSoft because uh, mule is an animal which has been used since the ancient ages to carry the load and make a human being's life easy. But then we don't have anything like that for a developer. So MuleSoft is a developer's friend now, which wants to carry this load and uh, give you enough time to focus on the business problems than the boilerplate code or the tedious tasks of the integration. Uh, that being said, MuleSoft is a lightweight ESB, and it is distributed and self-service. So it offers a couple of features for you to scale up and scale down, and gives functionalities on in an Exchange portal where you can share your code and help other developers to utilize what you have built rather than they creating a new module for their application. MuleSoft is developer focused, and by that what I mean is that usually projects are business focused, where we try to cater to business needs. But then MuleSoft keeps developer at the center of everything and empowers them so that they can innovate on projects and help business grow. So with that being said, the last one is transformations. By transformations, what I mean is MuleSoft provides a capability of transforming between file formats and then your message uh, data, so that you can quickly get through the transformations in order to uh, establish a contract between two systems or cater to the needs of two different systems. So they do it with a language called DataWeave, which is proprietary to MuleSoft, and that really speeds up the timelines for writing these transformation logic. So little bit of philosophy here. Wanted to cover API-led connectivity. Again, before that, wanted to introduce what an API is. So API is uh, the full form is Application Programming Interface. There are a couple of definitions online, but then this is basically an abstraction layer for your data services and code. So you can unlock your data, a service, or any code that you can use across your organization using simple technologies like HTTP. And again, these services can be invoked through your browser technologies like Chrome or Mozilla. So that's how simple these are. The popular ones are REST service and SOAP services. So these are widely used across the industry. Again, here we are trying to solve the solution that we had, solution for the problem that we had earlier. This is the same loan application I went through in the previous slides. So if you notice here on the swim lane, we have system APIs, process APIs, and experience APIs. So each of these layers have certain role and then a certain philosophy. Um, and that basically drives the design of these APIs, and eventually we get a successful API product on the top. So on the system layer, we have three different system APIs for getting the customer data. One is for customers, and then the next one is for the call center, the third from the database. So we have unlocked this data here so that we can use it for any other functionality that may come up in the future. Similarly, we have a ledger API, and for both of these payment systems, we have these payment APIs. So in this layer, what we are doing is we are invoking the data from the system, we are invoking the services from the system so that we can orchestrate them in our process API. So the next one is the process layer, which is basically orchestrating using these APIs in order to aggregate this data in the customer API here, which will have the customer data for all the customers in the organization. And we have your loan status API, which will in turn consume this customers API with the ledger API. Similarly, the payment calculator API, which is using the customer API and the ledger API, and the list just goes on. So if you notice here, we have just one service which is doing the the work that it has to do, and there is no duplication of any service or data that is being unlocked. So what this philosophy does is it basically helps us organize our code better and then promote reusability. So for instance, we come up with a new API which we want to build, and we want to create a new API for, let's say, an iPad here. So we can just create a new experience API, which is again an orchestration uh, of these process APIs. And we can leverage the functionalities that we have developed earlier in order to quickly innovate and get to the market on time. With that being said, let's move on. So here again, I wanted to emphasize on the value itself. So every product that we create in the API network adds value to your services. For instance, uh, you have this payment calculator service. So it basically added value to your entire organization. So you can use this payment calculator across your organization. You have this payment solution here. So payments are widely used in applications. Let's say you have 100 different applications which are accepting payments. So you don't have to write your logic again and again. So creating this API and the payment gateway API basically added value to your entire organization. The second concept I wanted to focus here is security. Each of these APIs have different needs in terms of security and governance. For instance, payment APIs will need a different kind of security. You may want to secure it more as it's a service. There are different API policies you can apply here. There's a different team that is responsible for these. You have your customer data. So customer data is again owned by a different team, and then you have this database customers API, right? So as this is a database, you may want to introduce SQL ingestion. So every module or API that you're creating here has different security needs, different governance needs, and then again, these APIs are visible to all the organization. So once you post it on the portal, the MuleSoft Exchange portal, any user can see it and ask permission to use that API, and relevant governance teams can go ahead and provide them approval to use it in their systems. The next one is adapting to change. So gradually, let's say in this API project, you want to introduce a new project, right? Let's say you want to do a machine learning project wherein you want to mine on the customer data and then provide them recommendation on products, then as you already have your customer data here, you can pull that information, put it in a machine learning model, and then get started right away. You don't have to go to your end systems to unlock anything, any data or services in order to cater to that need. Another example I wanted to mention is you have your payment services here, right? PayPal and Visa. Maybe your business is not comfortable with Visa anymore, and then they want to use MasterCard or any other payment technologies like maybe Chase Bank or something. So you can quickly remove this payment technology and then add a new feature here so that you can adapt to the change as and when the business needs. Uh, so that really helps a business to make decisions based on the flexibility and not based on the technical challenges that they might face. With that being said, I wanted to cover some of the AnyPoint platform concepts. So why MuleSoft is so popular in the market is that it is a platform as a service. Uh, by that, what I mean is we have your applications. Let's say you take a typical Java application. You have a Tomcat container. You have a Java application that is built somewhere, and then you have your servers, and the list just goes on, the bucket list that you have to create just to install the infrastructure, install your softwares, and then develop is really challenging. So it takes up a lot of project time, and then the effort is incremental, which goes across the organization, right from infrastructure, networking, and your application development teams. So what platform as a service offers is it offers a list of services or tools that can give you a bunch of features that you can use in order to complete your application lifecycle. It basically eliminates or minimizes the need of infrastructure teams or networking so that you can focus more on the application development and cater to the business needs. So MuleSoft has a couple of infrastructure components in the platform as a service, and I quickly wanted to go through them so that you are familiar with some of those and then what they do. So the first is Design Center. So the Design Center offers tools for development of your MuleSoft flows, mocking of your APIs, and then basically get the customer feedback from the mocked APIs. So while you develop an API, right, you don't want to uh, put a specification and create the API right away. You want to basically design it first, check with your customer on what they feel about the data and whether it is as expected or any modifications are needed. And that is when you want to get to your next step of development. So the design center basically offers tools to for you to get to uh, your customers and then get the feedback appropriately. Uh, the second is Exchange. So this is an interesting one wherein once you develop your application, you want your services to be discoverable across your organization, right? For instance, in the last slide, we went through the payment solution. So once you create a payment solution, you want to put it on a portal, and from that portal, any developer in your organization should be able to self-serve and ask for permissions to use that API. So with that, you promote uh, this concept of reusability, where your organization is reusing something and not creating the same code again and again on the applications. Next, there's a management center where you get to manage your APIs, uh, apply API policies with security. Then you can basically do operations where you can monitor how your apps are running, if there are any alerts, health checks, and so on. Then you can do analytics as well. So you can check for transactions per second, latency. Geographically, you can see where the API calls are being made, and then how those are being catered, so that uh, you can manage your entire API within the same console. The next one is connectors. So MuleSoft has a bunch of connectors. Uh, I would say thousands of them which are free, and then there are some proprietary ones. Some of the major ones that you get to use are the database connectors, which is a JDBC flavor of connector, which you can use to connect to databases like Oracle, SQL Server, MySQL, and the list just goes on. And then you have your SaaS applications like Salesforce, Workday, SAP, and then you can connect to your file-based systems. Like if you want to connect using an SFTP connection and read your files, there are connectors available for that too. Uh, then there is a runtime engine. So all your apps in MuleSoft that are being developed run on a container called runtime engine. This is where your apps reside, and you get to deploy them. Uh, and then you have your runtime services like uh, MQ and a bunch of services which help you run your services efficiently. So this is a typical development lifecycle. I wanted to emphasize on the design. As I talked about, you have all these functionalities where you can develop a design, mock the API without any need of uh, a test database or anything like that. And users can play with the design and see how that fits in. And it also helps your stakeholders, like other teams, to use those mocking services to get started uh, on their projects. For instance, there's a web application that is being built based on the API you're creating. Once you establish the contract on the design using a RAML or an open API specification, you can just mock that service, and your web application team is ready to go with their development. The next is development and test. So in this, based on the design, a MuleSoft flow is created, and then this flow will basically put all the functionality that is needed. For instance, if you're developing a system API, you would focus on pulling a data of customers from your database, and once that is done, you can test that service as well using munit, which is a framework that is used to test the mule flows. Once that is done, again, you can go back to the customer and get their feedback on the flow, because the flow is visual as well. The next step is deployment. Uh, so in this, you can have different environments like dev, test, and prod, and then you can manage the promotion of these APIs easily using your runtime manager and move these applications to your higher environment. Uh, this step again can be used for customer feedback. So gradually, once the API goes into your test environment, you can ask your QA team to test the APIs, and you can ask your other stakeholders to see how the integration works and if it is as per the expectations. Uh, the next one is operations. As I mentioned, we have the runtime manager, which provides uh, operations capability. You can set up alerts, manage your APIs, uh, and check for health. So again, let's say your API has to uh, have a certain rule that if the number of transactions per second is more than 500, you want to notify your users that in a window of 1 hour you have 500 users, then your users can be notified and they can check the application uh, and take appropriate action on that. So with that being said, I just wanted to give you guys some takeaway on what are the next steps in terms of design and development. So some of the core concepts that you should be learning now are HTTP, because HTTP is being widely used for REST-based applications because of its architecture and the way it is structured, and its support for browsers, and its ease for using it across organizations and also business to business kind of projects. So there are typically 4 different methods in that. You have get method, put method, and post method. So you can go over these concepts to understand how those can be beneficial creating an API. The second is API design itself. So while creating these projects, right, so you have to understand what services are reuse, or uh, what is the potential of a service for a reuse, right? For instance, while breaking down your application into different components, it is often easier to break it down because you have an overall picture of what you're building. But at the same time, you should also think about any future projects that may come up, or anything that you would build in future that can reuse those APIs that you are breaking down in the process. So you should have that kind of a mindset in order to design your APIs. So there are a couple of tutorials and articles online as well as on the MuleSoft site. So you may want to check that out. So the next one is design. So in order to design an API, there are a couple of specification languages that you can use. So the one that is natively supported by MuleSoft is RAML. So here you can create, for instance, a API specification for a REST service, right? You can have the get method and then what parameters are allowed, and different validations and so forth. So it basically helps narrow down on all the possibilities of data that you can pass in, the parameters. So in a way, it secures your API by establishing this contract. Uh, The next one is Open API specification. This is again a Swagger specification and now being renamed as Open API. Again, this is a popular one as well. It does similar stuff as what RAML does, but then this is a industry standard at this point of time, and MuleSoft has recently put in support for that as well. So the next one is development. So in order to do development in MuleSoft, you have a bunch of connectors that you can use. There's a desktop tool called AnyPoint Studio where you can develop your flows, and the IDE itself can interact with your AnyPoint Exchange, the platform as a service, and uh, basically get your design and then help you with the development and take it through the course here. So one language that is widely popular, especially on the MuleSoft ecosystem, is Data Weave, which allows you to transform your incoming requests and then massage your data. So there are a bunch of uh, functions and functions that MuleSoft provides for you to do what you need to do the best way with minimal code. Uh, it also seamlessly converts your data from one format to another, for instance, JSON to a Parquet format or XML to JSON, just by putting in some headers on the transformations. With that being said, you may also want to check out Java and Groovy. Java because uh, you may want to develop custom connectors when there is not one available on the MuleSoft exchange. For instance, you may have a custom application with a very specific protocol that is being used, and MuleSoft may not have a connector for that. So you can create a custom app and then build a connector and publish it to your exchange. And it then becomes another component on your exchange, which you can drag and drop into your flows and reuse it across multiple projects. Again, Groovy is another language too, which you can use for similar purposes and any scripting needs that you may have. So with that being said, I hope you guys learned something in this session, and uh, and I hope you get excited on your MuleSoft journey, and I was able to be a catalyst for you guys here. If you guys want to stay in touch, here is my LinkedIn URL. So feel free to follow me or connect with me. Uh, Thanks again for joining this session.